In an age when algorithms and servos join the soldier's kit, modern war is being mechanized in ways once reserved for science fiction. Robotics are no longer just aerial loiterers or remote sensors. They are becoming tireless gunners, ammunition mules, and even armored assault leads. And recently, Russia is upgrading their robotic combat to join assault unit. Let's take a closer look. Russia's newest robotic gunners and assault complexes are being rolled into attack formations at a moment when standoff strikes and close-in mechanized pressure are being synchronized. And the result is a battlefield that is faster, more remote, and ruthlessly efficient. The missile footage itself is stark. Twilight scenes interrupted by the thunder of cruise strikes, buildings split by detonations, glass and concrete thrown into the air. Yet while cameras are fixed on collapsing facades, something else is moving across the same theater. Tracked units with cameras where eyes once were, fitted with heavy cord machine guns and automatic grenade launchers, advancing to exploit the damage or to finish what the missiles began. Russian state releases and frontline clips now show a platform officially called the Multifunctional Ground Robotic Complex. The Courier, operating with assault units, supplying ammo, clearing obstacles, and delivering direct fire on enemy positions. According to Russian sources, the Courier has been tested near frontline villages and used to suppress positions, while infantry or mechanized elements seize the initiative. The introduction of Courier is not merely an incremental hardware update. It signals a doctrinal shift, where earlier unmanned ground systems were largely scouts or small bomb carriers. Courier is presented as a multifunctional combat assistant, a tracked vehicle that can mount a heavy cord machine gun, an AGL, or a Kalashnikov pattern machine gun, while its forward and rear cameras provide operators the situational awareness needed to perform both combat and logistic tasks under fire. Russian press materials and battlefield statements paint it as a system that can carry supplies, lay anti-personnel obstacles, and, critically, suppress enemy fire long enough for human assault teams to close. The platform's compact track design emphasizes maneuverability across broken terrain, and its modular payload options make it a flexible tool for frontline commanders trying to maintain tempo. Courier, however, is not the only robotic idea being trialed. Parallel tests and demonstrations point to a heavier tier of robotic combat: a robotic assault tank and its command complex. Reports describe a Shturm-type robotic assault vehicle being tested in controlled trials, a vehicle that can carry a shortened 125mm main gun with an autoloader, coaxial machine guns, and variants armed with rapid-fire 30mm cannons or rocket thermobaric packages. These robotic assault complexes are paired with a control vehicle derived from modified MBT chassis, designed to coordinate multiple unmanned fighters in an assault formation. The concept is clear: use robotic vehicles to lead breakthroughs, clear urban obstacles, and absorb first-line risk, while remote crews direct lethal engagement. Viewed together with the cruise missile strikes, a pattern emerges. Long-range missiles inflict strategic or operational damage from afar, destroying logistics hubs, command nodes, or choke points. Robotic gunners and assault vehicles then move into the resulting seams, doing the tactical work of securing ground, hunting survivors, and suppressing local resistance. Missiles create the gaps. Robots are engineered to crawl through them. This layered use of standoff firepower and uncrewed ground units reduces the immediate exposure of human attackers while maintaining relentless pressure on defenders. Yet capability claims should be matched by caution. Russian reports emphasize Courier's battlefield value: suppressive fire, obstacle deployment, logistical runs in difficult terrain. Independent confirmation of many performance metrics is limited: how the system performs under sustained counterfire, how resilient its control links are to electronic warfare, and how maintainable it is on a contested logistics trail remain open questions. The heavier robotic assault concepts amplify these uncertainties. A robotic 125mm gun or an autonomous squad of tracked assault vehicles is only as useful as its command, sustainment, and resistance to jamming and physical sabotage. Comparing Russian developments with Ukrainian robotic efforts highlights both convergence and divergence. Ukraine has fielded a range of UGVs and robotic aids, from reconnaissance crawlers and mine clearers to small attack carriers and modified civilian platforms turned lethal. Many Ukrainian systems emphasize modularity, low profile, and rapid adaptation, improvisation that has proven effective on a contested front. But the Russian push, as embodied in Courier and the Shturm experiments, leans toward integrating heavier firepower and sustained assault roles into unmanned platforms, pushing UGVs from support roles into the spearhead. Where Ukrainian robots often excel at asymmetric or defensive tasks, Russian designs are being tested for offensive combined arms roles. The gap, however, may be less about concept and more about scale, logistics, and battlefield maturity. The real test is whether these systems survive the chaos of combat long enough to change outcomes. The interplay between missiles and robots also reframes countermeasures. If cruise strikes are the punctuation of modern conflict, robots are the sentences that follow. Defenders will not only need air defense and hardened bunkers, but active counter-robotic measures, short-range anti-UGV weapons, targeted jamming and cyber operations against control links, physical traps, and tactics that deny robots the mobility and line of sight they require. Urban areas, where missile damage concentrates and rubble creates broken terrain, become simultaneously inviting and perilous for robots. Inviting because robots can enter hazardous zones without risking crews. Perilous because rubble, electromagnetic interference, and small unit ambushes are classic killers of mechanized systems. Finally, there are ethical, legal, and operational implications. Robots that fire lethal weapons in concert with long-range strikes complicate attribution, accountability, and proportionality assessments. Who bears responsibility if a robot misidentifies targets inside destroyed urban blocks? How do commanders balance the tactical benefit of remote suppression against the risk of civilian harm and escalation? These are not hypothetical questions. They are practical quandaries that will shape doctrine and procurement decisions as more nations watch these experiments unfold. That's all for today. Thanks for watching.